Alright guys, in this video I'll be doing a quick illustration of road design without you have to do anything with me. It's just for you to understand the process and the terminology and the methodology of the software. How does it represent a road design? I will show you in a minute the surface that we're trying to create. First of all, you'll see later on I'll be creating some points. And these points here. Remember a minute ago when I was talking to you about this surface here, I said each one of these points represented in a horizontal, or let's call it X, Y, and Z component. In other words, we call them easting, northing, Z component. So if you look here, I'm entering these points currently. I've got those from the surveyor, the guy who was on site measuring these points and giving me the data. And I'm entering them as the point, north, east, Z, which is the height, and description. This is the type of information. As you can see, PNEZD. That means point, north, east, Z, which is the height, and the description. So that's what I'm asking the software. Read these points for me. I've got them saved on the file. You don't have these points, so you can't do the work with me. Just please have a quick look at the video, what we're trying to do. I'm waiting for the software to import all this data. The software has finished now. I can close that menu and I can't see anything, so I zoom to all, and that showed me where the points are. So there we go. That's what the software did already. Imported all these points and I can see the points now. All right. So we've got the points, each one of these points, let's have a, I'll select one of these points so you understand. So each one of these points has a easting, northing, and elevation. That's what we talked about. Value represents on the horizontal, vertical, or stop saying horizontal, that's X, Y, and Z. Or easting, northing, and vertical elevation. So we've got that information regardless. So let's create a surface from these points quickly. And I'll call it EG, representing existing ground, and okay. Great. Now what we did, we created a surface quickly. So having said that, yes, it was quickly, but it's accurate because that's all based on lots of numerical values that we have here for each one of these points in terms of northing, easting, and elevation. If we look at this surface, that's what you get the 3D view of that surface. See, so this is the surface here, showing small two hills and a small valley between them, and the creek running here between the two valleys, as you can see. If I zoom in, and as you can see, there's always that large number of triangles next to each other, what we call it the triangulation of the surface. Now, so you understand what I'm trying to do here, we will talk about this later on in a specific video for that road design. You can see there's an existing road here. You can see it here. If you zoom in, to that, there's an existing road there, and there's a small intersection here, and stops. And there's another existing road here. Let's zoom into that. Another existing road here with a small intersection. So essentially, what we are required to do to design a road going from here to that point to that point. Let's say there's a small town here that we need to provide access to it, and mainly we are trying to connect between these two roads. Let's say these two roads, they can't meet here, and that's what we need to create a connection between these two roads. This is our task, assuming. So the first thing, remember what I've done there to create horizontal alignment. I created, where is that? I created just a line. Let me open the other file. Go to horizontal alignment. No, I don't want changes to this. So remember the first thing I created there, that line here to represent the road. So that's exactly what we'll be doing here. I'll be creating what we call a horizontal alignment. I finished with the horizontal alignment with the center line of the road. Each one of these points along the road has a distance from the point 0. That's where we start at point 0, and that's what we call them changes or stations. Okay, so we can move that and change slightly our design for the road, and this is the main importance of this software that allows us to make lots of changes for our design. Okay, so let's say this is our horizontal alignment, step number 1. Step number 2, we agreed I need to create a cross section. So let's say I've got creating a cross section here, and let's call it number 1 regardless, and let's draw this cross section here, asking me what components do you want in this cross section. I'd say, okay, I need lanes to start with. Let's go to lanes. I need a lane to go here. What is the length of that? 3600, that's fine. And then a shoulder, we agreed I'll create a shoulder, and that shoulder, let's make it 600mm wide, and that would be 0.6 because in meters here. And we'll ask me where do you want that shoulder. I'll say start from here, and this is the shoulder. And then I'll add what we call it daylight, which is the cut and fill. We will learn later on what does that means. And that's it. So mirroring all these components to the other side. And this is my cross section. I'll just do a circle. Let me close this. We don't need it anymore. And let's draw a circle around it so we don't lose it. And that's our second component. Remember, I had to do that here too. When I drew, let's show the geometry here, view hidden geometry. Remember when I drew the first cross section there. Okay, so that's the part where I need to draw in on Civil 3D now. So this is our cross section. We've got our horizontal alignment. One last thing we need is our vertical profile. Remember, we agreed each road does have to have a vertical profile. So I'm saying draw the vertical profile along the existing surface. The horizontal alignment, select that and do that. And go here, draw the vertical profile, create. This is our vertical profile of the existing ground. So this is, again, remember here, on the vertical profile, we agreed the vertical profile shows the heights only of the road. So I'm going to do that. That's what the software did now. As you can see, we're doing step by step, horizontal alignment, cross section, and vertical profile. I've got all the components. Let's put them together into what we call it. Sorry, there's one last thing before I do that. This is the profile of the existing ground, but the software will ask me, design your own profile for the road. Where do you want the road to sit along this profile of the existing ground? So in other words, this is how the land, let me just hide this. This is how the land topography is. This is the profile, as if I take cross section, let's take a cross section here. What we currently have, so you understand, is to be rotated. Okay. What we currently have, as if we drew, that's what we have. Can you see that line here, the curve here? This is what we currently have, the profile of the existing ground. But it's not the profile, it's not the profile of the road. The profile of the road, it's for us to design. Okay, so if I look at this here, this is what we currently have, the profile of the land or the ground where we are planning on designing our road. Now what we'll do, okay, this is the profile of the land or the ground. Let me design my own profile for the road, because realistically I shouldn't create my road to be, and that will be that. Okay, I shouldn't be creating my profile to be, you know, moving up and down that much. I should make it a bit smoother. Okay, so that's what I'll be doing. And let me just fix the settings first. I'll choose a K value of 20 for both and go OK. You'll learn all these steps later on, step by step. Important to shift snap to end. There we go. So my road, I don't want the road to follow the ground everywhere. I'll make it smooth here and maybe curving to there and then finishing to here. End point again. And this is my road. So the blue line is where I want my road to be. The red line where the existing ground is. Okay? I shouldn't make my road follow the ground everywhere. You will see them in a minute what that means. The road in some areas, put it this way, the road in some areas will be higher than the ground. In some other areas, the road will be lower than the ground. So let's just lower it a bit more. I think it's a bit too high. Okay, so this is my proposal for the road, for the height of the road. We're finished with that. I've got all the components. Great. Cross section, horizontal alignment, vertical profile. Then what we can combine them together with what we call a corridor, which is the three components. That's the first 3D design of your road. You'll see in a minute what would be the outcome. So it's asking what alignment. This is the horizontal alignment, and this is the vertical profile for the what we created, not for the existing ground, and the cross section assembly what we created, and match the surface of the existing ground. And go OK. And this is asking me, this is your corridor. Continue and apply and rebuild the corridor. OK. There you have it. This shape here, guys, if I look at it in 3D, it's a corridor. In other words, it's a 3D design of a road. Let's have a quick look at it in a 3D view. What did we design by doing all these steps? So look at that. That's what we created here. A road that is with that cross section that we chose to do. So let's just see if I can rotate this so you can see the cross section. With that cross section that we created to do, we decided to do 2 lanes, 2 small shoulders, and then we cut and fill, or what we call it daylight, into the existing ground. And that road, as we agreed, in some areas, look at it here, in some areas it's above, like here, above the existing ground, in some other areas below the existing ground. Let me show you that in a better view by creating just one last surface. This will give you a slightly better understanding of what we created. This is the finished ground, what we created. So let's select that and look at it in 3D. There you have it. This is our road. Let's have a quick look. So a road starting from this intersection, what we agreed on. That's the starting point where the intersection is, the existing intersection, and finishes at the other intersection there. Here. And as you can see, this road here, let's have a quick look at it, sits in some areas above the existing ground. This is the existing ground. Do you remember the valley or the creek we had in the center? So this is the new road, sits above that area and cuts into the ground, sits below the ground in some other areas. Okay, so this is our road here. Maybe one last view I'll show you. If we drive along that road, that will show you exactly. If we drive from this point to that point there, that will show you how we go through this area here. We call it the cut area, and then through that area and the fill area. So let's do that. So this is our road here. And if I just go to drive, and there we go. So this is us driving on that road that we just designed. What we can see in front of us, let's just stop here and see if I can change that to a bit more realistic view. I think Now this is the most realistic view we can see. The point is, that's us driving along that road that we just designed, and we are seeing how clear the view ahead of us. So you can see there's an issue on the turns. Let me stop here and let's see where we're at. So we are driving, let's look at the road that we designed. We are driving from that point there, from this point here all the way there. You can't see all the road here, just graphic issues, but that's not a problem. But as you can see around these turns here, around these turns, there's a slight issue with the side distance, what we call it, or the distance how much the driver can see ahead of them. So it's a very important parameter for us. Therefore we have to just exit that, go back to the single. This is a very important parameter for us. We have to provide enough side distance for the driver to safely be able, let me show you. We usually show a target on a distance and show the target. Okay, so usually this target here is shown in a distance of 50 meters, and the target I'll make it only 200. That is 0.2. Okay, this is usually the target, and let's make that target in the negative 1.75 ahead of us. Perfect. So can you see that green block there? This is the target at 50 meters away from us, at 200 millimeters from the road surface. We have to make sure the driver can see that with enough distance in order to, for example, avoid a tree falling on the road, any hazard or danger on the road. So this is one of the important parameters for our design. So that will allow us to check that along the distance, as well as seeing the traffic coming in the other direction. So we have to have enough distance, especially around the turns, so the driver can have enough distance forward to see the traffic coming in the other direction. Alright guys, this is a quick view. As I said, look, I'll close all of this without saving even, just to let you know there's nothing really you have to memorize from this. All what I needed you to know from this is simply what steps we are taking to design our roads. These steps that will involve the horizontal alignment, the vertical profile, the cross section. We will learn them each one step by step. We'll learn the details how to do those. And in order to do that, we've got some theoretical information that we have to go through. It's the language that we have to speak. For example, bearing, what does it refer to? Which is very important to us. For example, when I was drawing, let's look back here from the top. When I drew the horizontal alignment, for example, we agreed it's a group of lines connected with curves. So usually it just simply has to have a curve here. So let's draw a curve, something like that. Let's say this is the curve, and then another line. This is what we call horizontal alignment. So a group of curves, sorry, I said lines, it's a group of curves connected with straight lines. Okay. Now, when we draw these lines, we have a scientific way of describing the length and the direction. It's not the angle, it's the direction of that line. Because that line is connecting, let's delete these two, this point A and point B. Let's say this is point A and this is point B. So if we're saying this line goes from point A to point B, that will be a description for the bearing different than from point B to point A. Therefore, and the distance between them, obviously we have to carry that distance, or we have to describe that distance. But you'll learn in this lecture in a minute, after this one, that each 2 points connected together, for example, point 1 and 2, are connected with a segment, we call it. This segment has a length of 22.9 meters and a bearing of 45 degrees, 10 minutes and 30 seconds. Anyway, look, let's leave that to the side. I'll go through those in the next video. But the point is that this is important information that we have to learn so we'll be able to use them. You don't have to memorize them, but you have to understand them. This is the important part. Alright guys, I'll see you in the next video and we will continue from there.